everybody, I'm Miss Elizabeth, and this is a Spark Lab presentation. It's produced and presented by the Spark team of the St. Petersburg Library System, and we are going to do some cool and fun and explosive science. We're going to do some kitchen chemical reactions, and these we're going to use items that I bet you have in your very own kitchen. So first off, we need to talk about what is an acid and what is a base. All right, I'm going to ask you, and I'm going to be looking for your answer in just a minute. Can you tell me some everyday examples of acids that you see in your house, in your life? Okay, on the count of three, I want to hear it. 1, 2, 3. And it is... Did you say that you have milk? That you have lemons or lemon juice? Or you like to drink orange juice or sodas? Or maybe you use vinegar in some of your cooking. Those are all acids, mild acids that we use every day. Acids tend to taste, the ones that are safe to taste, sour or tangy. And let me tell you another everyday acid, but one that we don't have too much to do with it because it's inside our body. That acid is the acid in our stomach, and that acid in our stomach helps digest our foods. Okay, so now it's time to talk about bases. Can you tell me some everyday bases? Ones that we encounter in all kinds of places. All right, it's time to count down, or count up, that is, to 3, and I want to hear your answer. 1, 2, 3. Did you say baking soda, or egg whites, or toothpaste? If you did, those are some everyday bases. They tend to taste bitter. Once again, the ones that are safe to taste bitter, and they often feel slippery in our hands. Again, the ones that are safe to touch. Okay. Some of those are mild ones we talked about. Let me tell you a couple of stronger ones that we don't need to be touching. A strong acid is the acid in batteries. We definitely don't need to be touching that. And a strong base is bleach or heavy-duty cleaning products. All of those, battery acids and bleach, cleaning supplies, are strong ones that we don't need to touch. Kids definitely don't need to touch, and adults, when they touch them, are being very careful. So, did you know there is a scale that describes how acidic acid things are, or how alkaline or how strong base things are? It's called the pH scale, and it measures from 0 to 14. And it's a little different, some scales, because sometimes it doesn't seem to make a lot of sense, but I'll try to explain it to you. So from 0 to 14, we said 0 to 6 are the acids, and the strange thing is the lower the number, the stronger the acid. So the acid that we're going to work with today, and I'm giving you a little hint, is a 3. Now, 7 is the neutral. It's neither an acid or a base, and there's really not many of those. It is what it is purified water is number 7, which is neither one or neutral. Then our bases are the higher numbers from 8 to 14, and it's the opposite of the way the acids are. The higher the number is, the stronger a base is. And the base that we're going to use is a 9. So we'll see that in just a minute. We're going to do 2 experiments today using the same base and the same acid. Our acid is vinegar, and our base is baking soda. Those are our 2 reactants. The reactants are the 2 things that when you put them together and they touch, they make a chemical reaction. And that's what we're going to have. So let me tell you, these are items that you see in the kitchen. We use baking soda for baking, or for, I don't know about you, but sometimes my fridge gets a little stinky, so I open up a box of baking soda and shove it in, and it helps the refrigerator smell good. And the other one, the acid that is vinegar. I like to have Italian dressing, and vinegar is one of the key ingredients for that. Vinegar is also a very safe, mild cleaner that we use sometimes. put these two items together, the vinegar and the baking soda, and you get a chemical reaction. I've got a few tips for you before you start your kitchen science experiment, or kitchen chemical reactions, which I like to call it anyway. Make sure you get an adult's permission before you start. Sometimes fun science can be messy, so you're going to wear an apron. In fact, you'll see me wearing one. You'll want to use goggles or sunglasses because vinegar, even though it's a mild acid, doesn't feel good if you get it in your eyes. Don't forget to do this somewhere that it's okay if things get messy. Your house, your adult can tell you it might be in the kitchen, it might be outside. Just a good place where things can get messy. And don't forget, science is fun and we want to have controlled fun. All right, here are our supplies. Here is a jug of vinegar. Next up is baking soda, both available at any grocery store. Measuring cup, nice one with a spout, makes it easier. A teaspoon, an empty bottle, and a balloon. And the first thing to do with the balloon is get it all nice and stretched out. I'm just stretching it with my fingers, and then I'm calling my assistant over, and he's going to just blow it up nice and full to get it all good and stretched out. Blow, blow, blow. Here it comes back. And that's my sound effect of the air escaping. Stretching it out some more, especially the opening. All right, first up, or second up really, we are going to pour 1/3 cup of vinegar. Find the 1/3 cup measure on the measuring cup. And then we're going to pour the vinegar in and check and make sure it's level at the 1/3 cup measure. Here it goes. Put that lid on. Yep, it's 1/3 cup. We're going to set that aside. And I need my helper. My helper is going to hold the balloon while I measure out the teaspoons of baking soda. So here's the first one. Dip it in, level it off, dump it in down deep into the balloon. Remember, we need 3. Here's the second one. That's 2. Here's the third one. Level it off, put it in the balloon. And while I'm doing that, he's making sure, my assistant is making sure it's down deep into the balloon. It makes a more fun experiment if it all comes out at once. All right. Now it's time to pour the vinegar into the bottle, water bottle, empty small Gatorade bottle, you pick. It's nice to have a measuring cup with a spout. There we go. Up. We're going to stretch the balloon onto the top of the bottle and try to get the balloon centered on the bottle so it kind of dumps easily. So here we go. I've got it almost ready. 3, 2, 1. Dump or let go. Can you see it pouring in? Look at those bubbles. So cool, so cool. And what's happening? The balloon is filling up. So they reacted and we got an awesome reaction. That was pretty cool, wasn't it? I had fun. I bet you will too. That was lots of fun. What happened? You're right. When we mixed acid, the acid was our vinegar, with our base, which was baking soda, we created carbon dioxide. That carbon dioxide, after it was created, then went upwards and filled the balloon and made the balloon expand. And that was pretty cool. So we're going to do this experiment again, but just a little bit differently. We're going to make it a little bit more interesting. You might want to go find a dishwashing glove, the long rubber kind, because we're going to use that, and we're going to use that on a glass. Could be a little creepy, could be a little scary, but it'll definitely be lots of fun. And this time we're going to still be using our baking soda and vinegar, but our measurements for each one are going to be just a little bit different. So pay attention to those change in measurements. It's time to get scary. Here's what we need. Our first reactant is white vinegar. Any kind of vinegar will work. Baking soda, available in any grocery store. Tape. A dishwashing glove, the star of our show. A teaspoon. A measuring cup. And a drinking glass. Make sure it has a wide mouth and the glove will fit on it tightly. The first thing we're going to do is fold the glove back on itself, make a little cuff so there isn't so much space for the carbon dioxide to fill. Then we'll put it aside. Next, we're going to pour a half a cup of vinegar. Make sure you know where the half a cup is on your measuring cup first. Just makes it easier when you go to pour. There it is. And you pour right to that line. Here it comes, pouring away. All right, got to put that lid so we don't drop it all over the floor. Here we go. We have a nice half a cup ready to go. We're going to just go on and pour it in the drinking cup. I need my assistant again. It's time for the 4 teaspoons of baking soda. And they'll just go directly in the glove. So measure, level it off with your finger, and then dump it in the glove. That's 1. That's 2. That's 3. And that's 4. And my able assistant is shaking all the baking soda down to the tips of the fingers. So now get the glass ready, and we're going to put the glove on the glass, and we want to put it on nice and securely. And then this is what the tape is for, to keep the glove from falling out or falling off. It's a pretty fun explosion. All right. Last piece of tape. And then 3, 2, 1. Shake it down, and you can see the white where the reaction is already starting to happen. Look at that! The carbon dioxide, the pressure of the carbon dioxide has inflated the glove, and it's nice and full, and this looks pretty cool. That was pretty cool. I really enjoyed that. And now it's time, and don't try this at home. Whoosh! There went the glove. That was some pretty awesome science. I really enjoyed watching that chemical reaction. So we mixed vinegar together with baking soda, and we created a really wonderful chemical reaction with a byproduct of carbon dioxide. As you saw, the glove kept getting bigger. So when more of the baking soda kept dissolving into the vinegar, we got more and more carbon dioxide, which put more pressure on the glove and the glass. And it had to go somewhere. That carbon dioxide, it had to go somewhere. And so what it did was it pushed up and expanded the glove. How did you know a reaction happened? What did you see? What did you see? Did you see bubbles? What did you feel? Can you tell me what you felt? Did you feel the temperature change? Did you happen to put your hands on the glass, and did it feel a little bit colder? Carbon dioxide is like air. We can't see it. So we didn't see the actual byproduct, but we did see other parts of the reaction. We saw the bubbles in the glass, and then we saw the glove open up and expand, and that was a result of the carbon dioxide. Did we have some magic? Okay, it felt like magic, but it wasn't magic, it was science. We created a chemical reaction with baking soda and vinegar, and it was fun. Or if you'd like to know the more scientific way to call it, we mixed our two reactants, which was sodium bicarbonate and acetic acid, to create the carbon dioxide. So what we can learn from this is an acid plus a base equals a chemical reaction. Or you might like to say it this way: baking soda plus vinegar equals carbon dioxide. Don't forget to have fun with your kitchen chemical reactions and be safe. Thanks, and have a great day.